In today's video, you will learn about logarithm. So let's start off by looking at this exponent. 2 to the power of 3 equals 8. It's a very simple exponent. But we can convert this exponent into a logarithm. Log 2, 8 equals 3. So the 2 right here, the little subscript on the log, is the base of the exponent. The 8, the number in the brackets, is the result of the exponent. And the number that goes after the equal sign is our exponent. So this right here, log is a function that basically says 2 to the power of what number equals 8. So let's look at this example. 5 to the power of x equals 625. How can we write this as a logarithm? Well, we start off by identifying what our base is. So our base is 5. So we have log 5. And in our brackets, we will have our result, which is 625. And at the end, we have our exponent, which is just x. So we can rewrite this as log 5, 625 equals x, and x equals 4. So what we're essentially saying with this is 5 to the power of what number equals 625. And by using log, we can figure out what x is. Now, what if our base is the same as our result, log b of b? Well, it would equal 1, because what we're saying is b to the power of what number equals b? And the answer is 1, because if we have 5 to the power of 1, it'll equal 5. 6 to the power of 1, it'll equal 6. So we're just saying b to the power of what number, which will always be 1, equals b. Let's look at our first logarithm law. Log bm plus log bn equals log bm times n. So what this is saying is that when the bases of all our logs are the same, we can take log bm, we can take the m and the n and multiply them together and merge it as one log. So we can prove this with an example. So log 3, 9 plus log 3, 27 will equal log 3, 27 times 9. And upon evaluating, we get 2 plus 3 equals 5. And we now know that both sides equal 5. Now, another way to prove this is by taking the answer. So log 3, 27 times 9. And we can rewrite this part, 27 times 9, as log 3, 3 to the power of 3 times 3 to the power of 2. So by using exponent laws, we get 3 to the power of 5. We simply took the exponents and added them together to make 5. So when we're adding two logs with the same base, we're essentially adding exponents. And when we add exponents, we're multiplying the two exponents together. And this is why when we are adding two logs, we multiply their result together. So now let's look at our second logarithm law. Log bm minus log bn equals log bm over n. So in this example, m and n are being divided together if the two logs are being subtracted. And we can prove this with an example. So log 264 minus log 28 will equal log 264 divided by 8. And upon evaluating, we find that both sides equal 3. Now similarly, we can prove this. So if we have log 264 over 8, well, we can rewrite this part, 64 over 8, as log 2, 2 to the power of 6 over 2 to the power of 3. And by using exponent laws, we can subtract the two exponents, and we get 2 to the power of 3. So when we're subtracting two logs, what we're doing is that we're subtracting two exponents. And we subtract two exponents when two answers are being divided together. So which is why when two logs are being subtracted, we are dividing their results. Now here's our third logarithm law. A times log bm will equal log b m to the power of a. So what this is saying is that when we have a number multiplied to a log, then the result will be the number, the result, the m, to the power of the number we're multiplying, the a. And this is because, well, when we're multiplying something, we're doing repeated addition. So let's say a was 2, then that would be log bm plus log bm. And since we're adding these two together, we can simplify it as log bm times m, which is m squared. So when we're multiplying a log by something, we're just adding it over and over again. So we can write it as an exponent. Now let's look at log 2 4, and how can we write this with a different base. So instead of using 2, we can use any base and write it as log b4 over log b2. So what this is saying here is that b can be any number, so it can be 10, it can be 15, and once we divide the two logs together, we're going to get log 2 4. And to get this, you take the result, the 4, and set it as the result of one of the logs, the numerator. And then we take the base, the 2, and you set it as the log of the denominator. And now b can equal any number you like. So in your calculator, you can do log 4 divided by log 2, and you're going to get log 2 4. Now let's look at natural log, ln x. What is natural log? Well, natural log is basically saying log e to the x, where e is equal to 2.72, which is Euler's number. It's an irrational number similar to pi. And when we're doing the natural log of a number, we're basically saying e to the power of what number equals x. That's what natural log of x is. So what if we had the natural log of e? Well, e to the power of 1 is equal to e. So whenever you see this ln, it's basically saying log e of x. E to the power of what number equals x. So if you have any questions, you can leave them in the comments below, and they will be answered as soon as possible.